In this short video, I'm just going to walk you through how to interpret an SPSS output for a one-way between subjects ANOVA. So up here in this first table, we have our descriptives. So here are our treatment conditions, 1, 2, and 3. They have an N of 6 in each group, so a big N of 18. And here's the mean for treatment 1. Here's the mean for treatment 2, the mean for treatment 3. We're also given standard error for each treatment group and standard deviation. So if you needed to make a table or a figure or write it into a results section, that's where you would find those means and standard deviations or standard errors for your different treatment conditions. Down here at the bottom table labeled ANOVA, we have our ANOVA output. So this should all look familiar. It's what we've been doing. So first, they have the sum of square deviations for between subjects. So this is your SS between. This is your sum of square deviations for your within subjects. We have our degrees of freedom for between subjects, just 2. So degrees of freedom at 2, meaning we had 3 treatment conditions, you can see up here. Within subjects, so remember degrees of freedom for between is k minus 1, and within it's n minus k. So we took 18, subtracted 3, which is k, and that gives us 15. We then use that to get our mean squared, so this is our MS between, this is our MS within, and remember that's just 84 divided by 2 equals 42. 88 divided by 15 is going to give us 5.867. We then take 42 divided by 5.867 to get our F value. And then this is our significance or our P value. So if we wanted to write that as we would in the literature, we report our F statistic, degrees of freedom 2, we get from there, degrees of freedom within, in our parentheses, equals, we report our F value, and then probability is equal to 0.007. So this is our degrees of freedom between, degrees of freedom within. This is our calculated F value, and this significance is our alpha level or our P value. Now, of course, if you were calculating this out by hand, you wouldn't know the exact P value, and you would write something like P is less than 0.05, which we've seen before.